Here we have a couple more reactions, cycloadditions involving 4 plus 2 electrons. So let's look at the first reaction. The first reaction here is your diene. We have this part is the part that is participating in the reaction, and we have 2 carbon atoms that will not. And this is our dienophile. Notice that we have 2 electron withdrawing groups, 2 esters. And also notice that the stereochemistry here, the dienophile is trans. We need to keep that in mind because the reaction is stereo-specific. Next, we're going to do the movement of electrons in a cyclic fashion. So we're going to do this over here and then that over there. And we're going to move those electrons here to make a double bond. Here I am using 2 electrons here, and 4 here is a 4 plus 2. So it's my Diels Alder cycloaddition. To do the drawing then, we're going to keep in mind the carbons that we're using. 1, 2, 3, and 4 here, and 2 more here. We're making just like cyclohexene structure. But we still have to, I forgot to do that. I need to add that. And 2 more things. The substituents here are trans, so I need to have those trans, Cu2T, so the other will be pointing opposite, right? And we can have also the enantiomer to that. But there's one more detail that we forgot here, which is, well, not forgot, but I left it to the end. Let's say the carbon here and this carbon here we didn't use. So that is going to be forming a bridge. This time we have a bridge that will have 2 carbons. So that's one type of drawing. But it's better seen if we use the, say, in perspective. So to make it, I'm going to draw it on the right-hand side here. So what we're doing now, I'm drawing the 6 carbon atoms this way. That's my double bond. And now my bridge has 2 carbons. This 2 here, and this 2 here. That's my bridge. And now I still have at the bridge, I have this group. And these 2 need to be added opposites. So we're going to be 1 up and 1 down. And the enantiomer to that with the opposite configuration here. Okay, that's one example of cycloaddition, again, forming a bicyclic compound. Keep in mind then, the atoms are being involved in the reaction, and these 2 were not, so these are part of the bridge here. Now, what the reaction that I have under is an example of a retro Diels Alder. So let's look at the reaction the other way. So it's like breaking this into 2 molecules, the diene and the dienophile. So let's identify the bonds that we'll be breaking. This part is going to be my dienophile. So I'm going to be breaking this bond. Let's highlight it. The 2 new bonds that I formed, which in this case were these 2. These were the 2 new bonds. Here I'm starting like over to the other side. So what I'm doing is breaking those bonds. And in doing so, I'll be moving electrons also in a cyclic fashion. I broke that bond. I'm going to move that over here. And this bond also breaks. So it's exactly the opposite movement that we did before. And now I am forming a diene. My diene is going to be now this, and I have a metal group here, and my dienophile. Notice that I'm making now a double bond here. But this is pointing in one direction and this is in the other. So now this is the trans. Okay, so we still is stereospecific in one direction and in the other as well. So this is an example of a retro Diels Alder reaction. If we were doing that on the molecule above, we would be doing exactly the same thing. Only that in my drawing is probably, that drawing is not that easy to see. So again, we identify the bonds, the new bonds. And those are the bonds that I made new are the bonds that I'm gonna be breaking in my retro Diels Alder. So now, I break this bond and I form top bond over there. It's gonna be double. This is gonna become a double bond. And this bond is going to break and form the double bond. And notice that here I'm making a double bond. This is that. And these are pointing opposite sides, right? And then the other part, here you're having this, the 6 carbon atoms that I had in my diene. So again, all I did in the retro Diels Alder was identifying these 2 bonds that would be the ones that we break to form the dienophile, which are these ones. So it's like opposite to the double bond. Say in the cyclohexene, these 2 are the bonds that you're breaking, and you form your cyclic transition state. You do your movement, and you get your diene. In your dienophile, keep always remember your substituents. These are opposites, so you're starting with a trans dienophile.